Question 37. 4 number cards are shown below. 3 numbers are missing. Now let's read. 2 cards have the same number. Okay. Only one number is 6 less than another. All missing numbers are greater than 15. Okay. So immediately from the time you read this, you know you cannot subtract 6 from 15 because all the other numbers are greater than 15. So the first thing you'll have to do is to add 6 to 15 and you'll get 21. It says the total of the 4 numbers is 70, determining the missing numbers. So what we identified so far, only one number is 6 less than another. So we have 15, we have 15 and 21, and 15 is 6 less than 21. So we have that. It says the total of the 4 numbers is 70. And 2 cards have the same number. So whatever we get for here, the same is going to be for here. Now that we know the total, what would we do? Add and subtract. So we would subtract the sum of 15 and 21, which is 36, from 70. And we will get 34. And what will we do with this 34? Remember, the last 2 cards have the same number. So we're going to have to divide 34 by 2, and that's going to give us 17. So the last 2 cards have the same number, and we met all of what they said. 2 cards have the same number. Only one number is 6 less than another. All missing numbers are greater than 15. The total of the 4 numbers is 70. And we found the missing numbers. And this is for 4 marks. Question 38. The rectangle ABCD shown below is divided into smaller identical rectangles. The area of the shaded portion is 3,600 centimeters squared. This is the shape given. We can see that we have 3 shaded portions. They gave us the width, which is 60 centimeters. We don't know the length. The question is telling us calculate the length AB in meters. What is going to be step 1? Step 1 will be to divide. Why would we divide 3,600 centimeters? We would divide it in 3 because the question told us that the shaded portion, which is 3 shaded portion, is equal to this. So to know the area of 1 shaded portion, we can divide 3,600 by 3, and 3 into 36 is 12. So we are getting the area of one of the shaded portion to be 1,200. So because they're identical, it means the area of each is 1,200. And these are what? Rectangles. Now, when you're doing a question, there are always more than one approaches that you can take. One of the approaches that you can take for this question is if you know the area of one small rectangle. Let's look at it. We know the area of one small rectangle. Here they are showing us that the width of 2 is 60. So half of 60 is 30. So we would know the area of 1. We know the width of 1. What would you do to find the length? What is the formula to find the area of a rectangle? Area of a rectangle is length times the breadth. Now, what did this question give us? This question gave us the area is length times the width. What did this question give us? This question gave us the width, which is 30. The question gave us the area, which is 1,200, but the question did not give us the length. So what would we do to find the length? We can divide the 1,200 by 30, and that will give us the length, but of 1. This 0 can cancel this 0. 3 into 3 is 1. 3 into 12 is 4. 3 into 0 is 0. So we are getting the length of 1 to be 40. So if you are getting the length of 1 to be 40, then the length of each is going to be 40. What would be the length of AB? You can multiply 40 by 4, and you will get 160 centimeters. And the question wants the answer in meters. How do we go from how would we change centimeters to meters? When you're going from a small unit to a big unit, you divide. So we divide by 100. Well, how do we divide by 100? We shift our decimal point 2 times to the left. After every whole number, decimal point is understood to be there. 1, 2, we're getting 1.6 meters. So this is one way to work out the question. Another way we could work out this question is, if we know the area of one rectangle, then we can work out the area of all of the rectangles we have here. And how much we have? 2, 4, 6, 8. Know the area of one, we can work out the area of. So for step 2, in our second method, we can work out the area for the 8. So we can multiply 1200 by 8. You will get 9,600 centimeters square. Now, if the area, let's write our formula again. How do you find the area of a rectangle? And this huge rectangle, the same thing, right? Length times the width. What do we know? We know the area. What else do we know? We know the width. So we have to find the length. So let's put in the values we know. We know the area. We worked out the area of it, this entire shape. It's 9,600. We don't know the length, but we know the width of the entire shape is 60. What would we do to find the length? We would divide by 60. This 0 cancels this 0. 6 into 96. 6 into 6 is 1. 6 into 9 is 1 with a remainder of 3. 6 into 36 is 6. 6 into 0 is 0. We are still getting the length to be 160 centimeters. And as we said before, we have to write our answer in meters, so we have to divide by 100. We are shifting our decimal point 2 times to the left. We are getting 1.6 meters. Question 39, part A. It says Fidel has 6 cubes, and we can see the 6 cubes given. He placed them side by side and stuck them together as shown below. Okay. Fidel placed 1 black dot on each face that is not stuck together. On the faces that are not stuck together, he puts a black dot, and they are demonstrating that here. Now, the thing about the question is you cannot see the dot on this side, and you cannot see the dot under. But remember, the only faces that are stuck together are these. Okay, so that's one of the things you have to recognize. Okay, you cannot see the dot on the other side and on the under, but you have to count it. You have to take that into consideration. What is the total number of dots placed on these 6 cubes? Well, on the ends, we have 1, 2, the one on this side, 3, 4, and the one underneath, 5. So we have 5 on this end. We'd also have 5 on this end. Let's check the ones in the middle. Here we have 1. Here we have 1, 2, 3, and the one underneath is 4. So we have 4 here. We have 4 here. We have 4 here. We have 4 here. We have 4, 1, 2, 3, 4. 4 times. 4 fours are 16, plus the 5 on this side, plus the 5 on this side, and the 5 on this side, that's 10. So we are getting the total to be 26. So some of you all may not have multiplied by me, but you will have count on. So let's count on. Here is 1, 2, on this side is 3, 4, underneath is 5, 6, 7, 8, underneath 9, 10, 11, 12, underneath is 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and on this side, which is not stuck, 26. So the total number of dots placed in the 6 cubes is 26. Now let's see what part B of this question is asking us. What is the greatest number of cubes that can be stuck together so that the total number of dots is less than 45? So they want cubes to stick together, but they want the dots to be less than 45. So what some persons will do, they'll say, well, okay, we'll continue the diagram that they have. Right? We'll continue the diagram that they have. We'll probably extend those in the middle and leave the ends. If we add some more cubes in the middle, how much more do we need to add? Right now, we are at a total of 26. Okay, 26. Let's use the blank ones on top here. All right, except the ends, we are considering them to be in the center. We already know the ends are 5. right? So we have 26 here on 6 cubes. Let's see how much more cubes we would need. So we already have 6 cubes. Let's see how much more we need. And we need to get less than 45. Now I can do it a different way, but I'm going to be counting 1 cube at a time. All right, so let's go. So in the middle, we have 26. This will be 27, 28, 29, 30. Remember, we're not checking the ends. The ends already accounted for. After 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. Remember, we can't cross 45, 43, 44, 45. So no, we have to hold it there. We cannot pass 45. So we have 6 cubes already. How much more cubes should we add in to get less than 45? 1, 2, 3, 4. 4 more. So that means the total number of cubes that will get us less than 45 dots is going to be 10. Now you could have done this same question differently. And as I said before, there are multiple ways to do the same question. If you know that in the first 6 cubes, you have 26 dots, and you are trying to get 45 less than 45, you could subtract 26 from 45. And you would get 19. So you want 19, and you will get 19. So we need to get less than 19 dots. So how much dots on the ones in the middle? Because we know the n is 5. The ones in the middle is 1, 2, 3, 4 dots. So if I group 19 into groups of 4s, how much will I get? How much times could 4 go into 19? 4 times. And I will get a remainder. All right, so I'm going to get 4 as well. So if I group 19 into groups of 4, I would get 4. And this is telling me that I will get 4 cubes. So you see, I'm getting my 4 irregardless. Okay, so again, more than one ways to approach the question, but you'll get the same answer. I chose to count so that using the diagrams that I have so that you can see the information. So we got 10 for this answer. The last question on the paper, question 40. There are 28 students in a class. The incomplete bar graph, so we need to see the entire bar graph, so I need to make it a bit smaller. There are 28 students in a class. There are 28 students in a class. The incomplete bar graph below shows the number of students who were absent for 5 days. So if the graph is showing us the number of students absent, so then we have to check for the number of students present. Okay. Let's read what they want. The mean number of students present for 5 days was 22. Complete the bar graph to show the number of students who were absent on Friday. So before we do that, let's go through, understand the bar graph, allow it to make sense to us before we get in. So the question is telling us this graph represents those absent. So on Monday, we have 8 absent. If we have 8 absent, how much would we have present? So you have to go back. The question said there are 28 students in a class. So if 8 is absent, that means 20 will be present. Tuesday, 2 students are absent. If 2 students are absent, then how many students will be present? You have to take away 2 from the total number of students in the class. You'll have 26 present. On Wednesday, if you have 4 absent, how many are present? You're going to have to take away 4 from the total number of students in the class. You'll get 24 present. On Thursday, if you have 9 students, look where it is, 8 and in the middle of 10. If you have 9 students absent, how would you know how many are present? You're going to have to take away 9 from 28 and you're going to get 19. So 19 is present. Now that we understand the graph, let's go back to the question. The question is telling us the mean number of students present for 5 days is 22. Now, what I said about the mean question earlier in section 2, what do I encourage my students to do? Once you get a mean question, set it up. Remember what you learned. The sum goes on top, the number of values goes underneath, and the mean comes here. So let us read this question and see what they gave us. The question is telling us that the mean number of students present for 5 days was 22. 5 days and the mean is 22. Why did they give us the mean and why did they give us the number of values? Like in the question in section 2, so that we can multiply to determine the sum. What is 22 multiplied by 5? 22 multiplied by 5 will give us 110. What does this sum represent? What does this 110 represent? If the mean number of students present for 5 days was 22, this is telling us the number of students present for the 5 days, including Fridays, 110. So to determine how many students were absent on Friday, let's check how many students were present on Friday. Since we know the total number of students present on Friday is 110. So what would we do to find out the students present on Friday? We would subtract the sum of all those that are present on the other days. 20 present on Monday, plus the 20 present, plus the 26 present on Tuesday, plus the 24 present on Wednesday, plus the 19 present on Thursday. So it will be 110 take away 89, and this is going to give us 21. What does this 21 represent? So I say you're working with numbers. You have to read the question to understand what your numbers represent. So this 21 will represent the number of students present on Friday. If you have 21 students present on Friday, how many students will be absent? If you have a total of 28 students in the class, 21 came. How many are absent on that day? 7. So your graph should go to 7. That's in the middle here. So we had to complete the graph to show the number of students who were absent on Friday. There is another way in which we can work this question out. And I've been saying that there are multiple ways in which we can approach a question. So I'm going to do over the same question, but using another approach. So the question told us that there are 28 students in a class, and the incomplete bar graph below shows the number of students who were absent for 5 days. Good. So knowing that, what we can do is if there are 28 students in a class, we could work out the number of students that will be present for the 5 days. So if 28 students is expected each day, then when I multiply 28 by 5, I will get 140. So 140 represents the number of students that is supposed to be present for the week, right? However, this graph is only showing us the number of students absent. So here we have 8, here we have 2, here we have 4, and here we have 9 students that are absent. And then the question goes on to tell us that the mean number of students present for 5 days was 22. So we know the total number of students that is supposed to be present, and then they are telling us that we can work out the actual number of students who are present. The question gave us the mean of 22 for the 5 days. So we can multiply 5 by 22. We can multiply 5 by 22 and get the sum, the number of students who are present for the 5 days. So the total number that is supposed to be present for the week is 140. However, the actual number of students who were present was 110. So if we subtract this, those who are supposed to be present from those who are actually present, what would we remain with? Those who were absent in that week. So we are getting 30. So 30 students were absent in that week. So if we know 30 students were absent in that week, if we add 8, 2, 4, and 9, that's going to give us a total of 23. So the total number of students absent is 30, from Monday to Tuesday, 23 is absent. So if we take away 23 students from the 30 absent students for the week, we will remain with 7. So that's telling us that 7 students were absent. So I'm just showing you all there are multiple ways you can work out the same question, okay? And this brings us to the end of the 2025 C Math past paper.